Welcome back, our grade 12 learners and teachers in physical sciences. Let's just find one exciting ways of solving a problem in electric circuits. We were given a question recently of somewhere around 21 marks. Let's try and make sense out of this. We are given a circuit. The statement preceding the circuit diagram says a battery with unknown EMF and unknown internal resistance is connected to 3 resistors, a high resistance voltmeter, 2 switches, and 2 ammeters of negligible resistance as shown below. Now the first question says state Ohm's law. That is 8.1. We know Ohm's law, all of us. Say the current in the conductor is directly proportional to the potential difference at constant temperature. You can start with the potential difference, also is the same, or one can state the relationship of the ratio. There is an or. The ratio of potential difference and current is constant at constant temperature. So also it's also a definition of Ohm's law. Find 8.2. Don't forget that Ohm's law deals with the relationship between current and potential difference. That's what you should know. Now they are telling us to say both switch S1 and S2 are closed. The reading on the ammeter A1. You can see where A1 is across 2 and 5 is 1.5. Calculate the reading on the voltmeter. We know that the voltmeter in the parallel combination is the same. The voltmeter across 2 and 5 is the same as V. Therefore, if you can find this one, then it will be the same as this one. So how do you find that? You'll say V equals to IR. Therefore, this will be 1,5 multiplied by 7. So this will be the same as 10,5 volts. That's the easiest one. So that's how to find. Once you find the voltage across 2 and 5, it will be the same as V. The second question, that is 8.2.2. 8.2.2, they say calculate the reading on A2. A2 is the total current in the circuit. The easiest way will say, now we know the voltage here, we know the resistance, we can find the current. We know that this current and this one, the sum of these two will give us A2. Therefore, the current R equals to V over I. Therefore, resistance is 3. And the voltage is 10.5 divided by the current. Therefore, the current here will be 10.5 divided by 3, which will give us 3.5 amperes. So if it's 3.5 amperes, then I will say, therefore, the reading on A2 will be 1,5 plus 3.5, which gives us 5 amperes. That's how you get to the reading on A2. Fine. Let's go to 8.2.3. 8.2.3. According to this question, they say power dissipated in the 3 ohm resistor. Remember, there are many ways to calculate power. Power dissipation will be either I squared R, or it will be either V squared over R in this case, or power equals to VI. Because you know all this you can choose the one that is suitable Then you just use okay, find the current across the 3 ohm is 3.5 all squared multiplied by 3. Therefore, if you use your calculator, you will get somewhere around 36.75. In all these cases, we get the same answer. That's how easy circuits. You have got options, lots and lots of options. As long as your interpretation is okay, spot on, then circuits will become very easy. Let's go to 8.3. They are saying to us, calculate the EMF of the battery now. Okay. A hint says switch S1 is now open. Can you see where is S1? That there's no more current flowing through 2 and 5. The only resistor now in the circuit will be 3 ohm. Fine. When switch S1 is now open, while switch S2 remain closed. Yes. The reading on the A2 is 3.64. When you open here, the reading on A2 now decreased to 3.64. Now they say calculate the EMF of the battery. I think in this case we'll have to use simultaneous equation. We know the formula for EMF in this case is E equals to I into R plus R. The first expression will be the one after the switch is open, will be now the EMF will be E equals to the current now is given is 3.64 into the external resistance is 3, and then the internal we don't know is R. That's our first expression. The second expression, for us to do it, we have to find the total resistance of the circuit first, of the effective resistance of the parallel. Therefore, the effective resistance of the parallel is very easy. Rp equals to 1 over R1 plus 1 over R2 all to exponent minus 1, which will be the same as 1 over 7, plus 1 over 3 all to exponent minus 1. Therefore, this will give us 2,1 ohm. I think that's the case. Now, once you have done this, then you will have to now come to the issue here of finding the expression now. When the both switches were closed, it will be I into R plus R. Therefore, the EMF, I don't know. The current when both switches were closed was 5, and then it will be now into 2,1. That is the effective resistance of the external circuit, and R. These are the two expressions. So you have got this, and also the EMF being equals to 3.64 into 3 plus R into 3 plus R small r. That's the 2. Now you solve the 2 simultaneously. Equate equation 1 and 2. Therefore, it means that now you'll find that 5 into 2,1 plus R small r equals to 3.64 into R3 plus R. Then if you solve the 2, you will use your calculator, find that the final answer will be now 0.31 for internal resistance ohm. Yes, then with this one you can now take 0.31 and substitute in any of the 2. Therefore, EMF will be now 5 into 2,1 plus 0.31. Then the answer of the EMF will be 12,05 volts. If a learner get to 12.04, it will still be accepted. Fine, it's a question of approximation. Instead of 3.64, the learner used 3.6. So that's how to find the EMF in this case. Hopefully this simultaneous equation very important, because you've got two situations whereby both switch S1 and S2 are closed. You have got the expression for EMF, and then we have another expression when now switch S1 is open. So you equate the two, because remember we said EMF and internal resistance do not change, they remain constant. Whether you are tampering with the external resistance or voltage or whatever, the EMF and the internal resistance remains constant in this case. Now, the last question they say to us, switch S2 is now open while switch S1 is still closed. Or switch S1 now is closed. If we open switch S2, we close this one. Now, what happens to the effective resistance? Remember, the effective resistance was 2.1. Now, if we open this one and close this one, the effective resistance between these 2 points will be 7. So it means that now the total resistance in the circuit has increased. Remember that explanation where now you are using the R external. Fine, you are going to use that table. In this case, you will find it to be. Yes, if you still remember, we talked about this table to say in explanations, please remember this. It will give you 4 free marks. Very important table. You may have to include it somewhere in your notes, and it will make life easy for this type of questioning. Let's answer the question now. They say when switch S2 is now open, we close switch S1. How does the voltmeter reading change from choose from increase, decrease, or remains the same? Remember the voltmeter reading here, which is this one, when we close switch S1, and then the voltmeter reading here, which voltmeter reading, how does the voltmeter reading change, which is this one. So obviously the voltmeter reading, if this is the 1, it will be now 0, because there is no current here. It will decrease. We write the word decrease now. It will decreases. That's the first point. Voltmeter reading decreases. V decreases. Now they say obviously give us the reason. Explain your answer. Now we start with the total resistance. To say the total resistance, R total. If you open switch S2, then R total will increase. R total increases. The total resistance of the circuit increases, but don't be lazy like me, right? The total resistance increases in the circuit increases. And what will happen to the current now? The current, total current will decreases, fine. If the total current decreases, then it means that now what will happen to the lost volts now inside the battery? We say the V internal, or the lost volts inside the battery decreases as well. Decreases. That's the end. You get 4 marks. 1, 2, 3, 4. So once the lost volts normally decreases, it means that now, according to this one now, the current in this one anyway decrease. So it will be using this 3. So the current decreased to 0. So that's why once the total current decreases, even this one will decrease. So, but anyway, it will be 0 in this case. Don't have to say decrease, but anyway, they wanted the word decrease. I think that's how we answer an exam type question in electric circuits. This was 21 marks. So just know the basics. Trace the current, trace the resistance and the voltage, especially the voltmeter readings. So if you can do that one, the questions on electric circuits will be very simple to you going forward. I hope you have learned a lot out of this discussion and out of this answering of this question. I wish you good luck in your upcoming questions in relation with electric circuits. And please write important notes and know the definitions, especially of the Ohm's law, internal resistance, and the EMF in this section. Good luck until we meet again in the next coming sessions, where we'll be dealing with also questions related to with the usage of Ohm's law and other related questions like your energy dissipation and the power dissipation. Sometimes they can not just say power, they talk about the rate at which energy is used. So you know that the rate or at which energy is transferred is the power. So that's how the examiner can hide behind those words. So until we meet again, thanks a lot. Bye.